So now let us see this problem here. A 345 inclined plane is fixed to a rotating turntable, and a block rests on the inclined plane, and the coefficient of friction between the inclined plane and the block is 1 by 4. The static friction, okay, coefficient of static friction is 1 by 4. The block is to remain position at rest position 40 centimeter from the center of the rotation of turntable. Find the minimum angular velocity to keep the block from sliding down the plane towards the center. All right, so this is a question here. So you have been given a turntable, so you can see here, and an inclined plane is kept here. Okay, an inclined plane and a block is kept on it. The dimensions of inclined plane are 3, 4 and 5. It's a right angle triangle. Okay, and the center of this turntable and the center of the line along I mean the vertical line from the block makes is at 40 centimeter. So this block is at 40 centimeter from the center of the turntable, and the turntable is now rotating with an angular velocity of omega, right? So we have to find out what is the minimum angular velocity so that this block do not slide down towards the center. So this will be the center, right? So it should not slide towards the center. So what should be the minimum angular velocity? So in order to find out the angular velocity, let us draw an inclined plane, the given inclined plane. I'm drawing the given inclined plane here. All right, so this is the angle of the inclined plane. Okay, and this is the block here resting. This is the block here, our block is here. Okay. And so this is our block, and on this, what are the forces which are acting on this block? Let us see. Okay, so first of all, the weight is acting down, isn't it? The weight is acting down, that is mg. The weight mg is acting down. This weight can be divided into two components. What are they? So this weight can be divided into two components. Weight is here mg. Okay, it can be divided into two components. One is, this is mg, and this is one component along the plane, and this is perpendicular to the plane. So this angle is theta. So this is your mg. So this is mg cos theta. Okay, and this is your mg sin theta. Okay, so this angle is your mg sin theta along the plane. So along the plane it is mg sin theta, and perpendicular to the plane it is mg cos theta. And the normal reaction to the plane, to this block, the normal reaction n is normal to the plane. Okay, normal to the plane. And since the block is sliding down, so there will be a frictional force, friction, which is acting in the upward direction. Okay, so now if you consider this normal reaction and the frictional force here, so what are the forces that are we will see that for this should be in equilibrium. So in equilibrium, if this block is to remain in equilibrium, right? So this block should remain in equilibrium. So if this is to remain in equilibrium, the block is to remain in equilibrium. Okay, so what should be the, if this block is to remain in equilibrium, so this, what is the condition for equilibrium? So let us take the equilibrium condition. Okay, so horizontal direction, if you take horizontal direction, this mg cos theta is acting. So mg has got two components. What are the two components? One is this is mg sin theta, this is mg sin theta, and this is mg cos theta. Mg cos theta. So mg cos theta, and then friction has got friction is acting upwards, isn't it? Friction is acting upwards. So, and one more force is acting here apart from this, and that is the centrifugal force. Okay, centrifugal force. See here, there is a centrifugal force, and that centrifugal force is acting away from the center. So this is your centrifugal force. Okay, so the centrifugal force has got two components. What are they? Centrifugal force has got along the plane and perpendicular to the plane. So two components are there. So this angle is theta. So this is your centrifugal force. So this is your Fc cos theta, and this is your Fc sine theta. So centrifugal force is acting away from the center. Okay, it is a force which is acting away from the, it is an inertial force. Okay, so it is acting away from the center. Okay, it is because of the inertial frame, the frame of reference. The force which is acting, it depends on the frame of reference which we are choosing. Okay, so so centrifugal force is acting away from the center, so it has got two components. Now if you see here, the friction, and what is friction? Friction, as you know very well, the friction is given by friction, the force of friction. What is the force of friction? The force of friction F is equal to mu into N, right? So you know this force of friction. Okay, so if you see here, there is mg sine theta is acting downwards. Okay, mg sine theta is acting downwards, so you can write mg sine theta, okay, that is balanced by two forces. What are the two forces? Frictional force, okay, and Fc cos theta. So that is Fc cos theta is acting upwards and frictional force is acting. So Fc cos theta plus the frictional force, which is mu into normal reaction. Okay, and if you see the vertical, so this is horizontal direction, this is along the horizontal equilibrium, horizontal, and if you want to take vertical, in vertical direction, what will be in vertical direction? Vertical direction, if you see, then the normal reaction is acting upwards, and mg cos theta and Fc sine theta is acting downwards. So that means normal reaction is balanced by mg, normal reaction is acting upwards, and mg cos theta is acting downwards. So mg cos theta and Fc sine theta. So Fc sine theta, right? This is the these are the two equations which you are getting. Okay, so if I rewrite this, I'll write here again. So mg sine theta is equal to Fc cos theta. So you will get mg sine theta is equal to Fc cos theta plus mu s into normal reaction. And normal reaction already you have written, that is equal to mg cos theta plus Fc sine theta. Okay, and from this, if you substitute for n here, so you will get an equation mg sine theta is equal to Fc cos theta plus mu s into mg cos theta plus mu s into Fc sine theta. So if you solve this, you will get Fc, you can eliminate Fc from this. So Fc you will get as sine theta minus mu s into cos theta whole divided by cos theta plus mu s into sine theta, right, whole multiplied by mg. And the centrifugal force, you know, is given by m omega square r, right? Centrifugal force is given by m omega square r. M and m will get cancelled, so you can just substitute the values here for sine theta and cos theta, right? So you will get omega square is equal to, this is what you are getting, sine theta minus mu s into cos theta divided by cos theta plus mu s into sine theta whole multiplied by, okay, whole multiplied by g divided by r. So that means your omega square will be equal to sine theta. Sine theta from the right angle triangle of this inclined plane, you can see it is 3 by 5. Okay, sine theta is 3 by 5 minus mu s is given as 1 by 4 into cos theta, which is 4 by 5, whole divided by cos theta, which is 4 by 5, plus mu s, that is 1 by 4 into sine theta, which is 3 by 5, whole multiplied by g, which is 9.8, and the radius, which is 0.4. Radius is given as 0.4, right? So if you solve this, you will get omega square is equal to 10.3, okay, or omega is equal to 3.2 radians per second. Okay, so this is the angular velocity which with which this is the angular velocity of this this turntable, the angular velocity of the turntable, minimum angular velocity of the turntable, for which the block should not fall down, isn't it? The block should not fall down. If the block should not fall down, then the angular velocity of the turntable should be equal to 3.2 radians per second.